try to introduce you to the idea of modules and packages, what we also call as libraries, right? So these terms are technically a bit different, but for a starter, we can interchangeably use all of these terms together, right? So you might hear about modules, you might hear about packages and libraries, right? So for now, you don't have to worry about the differences. Assume that, yeah, they are interchangeable in a way. Okay. All right. So let's talk about modular programming, and from that concept, we'll try to come up with the idea of modules and how Python has so many inbuilt modules or libraries which make our life a lot easier, right? So this is what we're going to learn today. So first of all, modular programming refers to the process of breaking a large, unwieldy programming task into a separate, smaller, more manageable subtask or module, right? So let's say if you want to do hundreds of tasks, right? You want to do umpteen number of tasks on a specific problem or use case, right? So you might write 100 functions if you wish, okay? And we can somehow group or write these functions in a proper structure, what we can also call them as components of the module. So we can have different functions within different, let's say, classes for a specific task. So it's sort of breaking down your bigger problem into several smaller problems, and you have functions and codes to fulfill your those specific set of requirements, right? Of course, it can do all the task. A module can do all the tasks within it, but there are specific set of functions or methods within those modules which we can use to complete our specific task. Okay, so there are a lot of advantages in terms of modularization of code, right? So first is simplicity, right? This is really important, and if you think logically, right, it will make sense, right? So you, rather than focusing on the entire problem at hand, a module typically focuses on one relatively small part of the problem, right? And then if you're working on a single module, you'll have a smaller problem domain to wrap your head around, right? So we want to keep our codes simple. We want to have greater accessibility to these codes in terms of understanding what they do, right? So that's why we have to follow a modular structure in terms of writing a piece of application or software for a major problem, right? So we can break it down into several small problems, and those modules will serve as tools to tackle those particular problems, right? The second component is, or second advantage is maintainability, right? So modules are typically designed so that they enforce logical boundaries between different problem domains, right? So this is really important. So when you start creating a module, or when you you get an idea and you want to build a module, right? So you need to understand that there are different boundaries between different set of problems, right? So you need to define which domain of the problem you want to work on, and thus you can start building a module, right? Of course, you will not be expected to build an entire module on your own, and that is of course for quite later, but to understand this concept, right? So it enhances maintainability, right? So let's say if different set of modules have very minimal interdependencies among each other, right? So if there is a particular set of task or action which you're doing using a specific module, and if let's say you encounter into some error, you'll have to probe into that specific module rather than going to some other module where that error might stem from, right? So you need to have such sort of maintainability, and modules provide us that flexibility to develop maintainable codes, right? So in terms of error, you want to find out what's the error you're encountering. So that's why modules are really useful. So you'll get the idea why I'm talking about modules. You'll get to understand this particular idea in just a while. Okay. And the third is reusability. So functionality defined in a single module can be easily reused, right? So by other parts of the application. So modules are designed in such a way that can be used again and again in different parts of the application which you're trying to develop, right? So we totally get away with the idea of duplicating our codes again and again, right? So that is not required. We can simply call a module and import those required functions, right, or import those utilities, and we can use those to solve our specific problems at hand. Okay, so functions, modules, and packages, they're all constructs in Python that promote code modularization, right? So you must be familiar with this particular term, modularization, right? So even in real estate, if you go to find a new flat, right, and a lot of people demand for modular kitchen, right? So you get the idea, right? So what is the meaning of modular, right? So you have a separate separate tools or separate soft codes which serve a specific task. Okay, and then you can bring all of them together in one bundle, and from there you can extract different sort of codes or functions for a specific set of tasks. Okay, so this is the meaning of modules, right? So I'll just try to give you the definition of modules. So modules are the predefined files that contain the Python codes which depict the basic functionalities of class, methods, variables, etc. Okay, so they consist of different functions and or classes in a group of files inside a directory. Okay, or there's also another term, modules can also be called as libraries. So they're basically the predefined methods that can be used to make the code more efficient and reduce redundancy, right? So you don't want to have duplicate codes, and that's why modules come in really handy. Okay, so it's essentially different set of codes bundled together, right? That is how you can think of modules. Okay, so modules bind the code and reduce the repetitions of functions frequently used in the code, and it makes the code much clearer and easy to understand, right? There's another point. So modules contents can be accessed with the import statement, and you haven't yet imported any such module as of now, right? So you have been writing very boilerplate codes up till now, and you haven't really worked with import statements where you're importing a particular module or library. Okay, strictly a library is a collection of modules. I told you that we can use these terms interchangeably, but you can imagine a library to be a collection of modules, right? So module is in a way a very generic term, and I think a library is a very specific terms in terms of programming, right? So we can call any module as library as well. Okay, so most of the libraries that we encounter, they only consist of a single module, so that's why it's very easy to interchangeably use these terms. But strictly uh, uh, a single library can contain multiple modules within it, right? So we'll of course deal with libraries in future, what are the different set of modules within it and what those modules are meant for, right? So we'll be exploring different libraries in our journey, and you'll get the idea how we can use these libraries, how we can smartly call any particular utility and use that particular function to do our task. Okay, so some popular Python modules which are available. So of course these are not exhaustive. You have hundreds of them, maybe thousands in fact, right? So because we have a very large Python developer community, and every day you'll see that there are hundred thousands modules coming up for different set of tasks, right? Or maybe if they're not doing any new task, they are sort of an improvement over the existing libraries. So first is OS, which is short for operating system. So all the operating system related characteristics can be uh, accessed or can be defined using the OS library. Then you have math. This is of course used for mathematical functions. Then you have time, which is used for daytime operations. You have matplotlib, which is a very popular library for data visualization, and will in fact be covering this towards the end of this particular week. Okay, so one such library in Python is Numpy, right? So Numpy is a very useful library, and this is what we are going to learn today: why Numpy and what is Numpy and what are the different functions and utilities within Numpy. So we'll be exploring a bit. Uh, okay, so Numpy is a Python package, as you already know. So we can call it as a library or a package. Usually people go with the term package. Okay, or you can also call this as a library. Doesn't make much of a difference. So NumPy is short for numerical Python. Okay, so it essentially deals with computations. Okay, so you want to do a lot of numerical computations in Python, and NumPy is a library meant for that, right? So this is a library which consists of multi-dimensional array objects and collection of routines for processing an array. So you will understand the concept of arrays, which are essentially, let's say, vectors and matrices, when we learn about linear algebra and the maths module. But for now, you can you'll understand the concept of arrays in a while. Okay, so NumPy provides us a lot of flexibility in terms of numerical computations, right? So it has a lot of optimized functions which can process your data, perform a large number of computations in a very optimized way. Okay, so NumPy package is widely used in machine learning and scientific computing, right? So essentially what NumPy is meant for, manipulating and crunching vectors and matrices, right? So you have a lot of data which can be represented in a form of vector or a matrix, and NumPy provides us a lot of flexibility in crunching those numbers. Okay, so a lot of, in fact, Python packages, they are built on top of NumPy. So you'll be learning pandas from tomorrow. So pandas is in fact built on top of NumPy. Okay, there are others, so TensorFlow, so that is used heavily in deep learning, right? So learning NumPy is a very handy thing, right? So you'll be able to use a lot of functionalities, but you don't have to go in a lot of detail. Okay, so whatever we I thought should be relevant for you in terms of understanding or doing exploratory data analysis, right? So those functions which we'll be discussing today, but there are in fact a lot more, because this is a really vast library. It's not possible to discuss each and everything, but we'll only be learning those stuff which are relevant for us, which are relevant for in terms of usage of NumPy in data science, right? NumPy has a lot of applications in deep learning, because in deep learning we deal with a lot of unstructured data. Okay, so I'll come back to this point in just a while. Okay, so NumPy offers very ingenious techniques for effectively loading, storing, and manipulating in-memory data in Python, right? So whatever computations you're doing in memory, okay, so NumPy provides a very effective and optimized way to do those things, right? And we, in our nature, right, so if you talk about different businesses, if you talk about different companies, right, so they're dealing with different sources or different natures of data, right? Most of the companies, they are dealing with simply numbers, but a lot of companies, they're dealing with text. A lot of companies are dealing with images or sound, right, or videos, right? So how can we represent these unstructured data in terms of numbers, right? So because numbers are what a computer can process, right? So they do not understand any text if you pass it to them. So they have to be processed in terms of numbers, and then eventually the computer will understand what is it. Okay, so there's one such particular unstructured data, image, and they can be represented as a two-dimensional array of numbers, or maybe a three-dimensional array of numbers, right? So this is really important, that we can represent very unstructured data such as images with a simple array of numbers, right, or simple matrices. So we'll be learning about matrices and vectors in the linear algebra classes in the next module. But for now, you'll get the basic understanding of what these array of numbers I'm talking about, and why I'm saying two-dimensional or one-dimensional or even multi-dimensional array of numbers, right? So you have a lot of unstructured data, and you want to process them in certain ways so that your computer can understand what is being fed. Okay, so we can transform images into some set of numbers. Okay, similarly, sound clips can also be thought of as one-dimensional arrays of intensity versus time, right? So we can convert sound into an array. Text also can be converted into an array. Okay, so let's say if you talk about a single word, for example, let's say collection, right? So there would be some vector space in which this particular word collection will be represented as a vector. Okay, so you don't have to worry much about these things as of now, but of course the terminology will become really clear in the next module when we learn about linear algebra and how we can uh, represent a particular text, if in fact a sentence, as a vector. Okay, so these concepts will come in handy, but I want you to give a basic motivation, as in our nature we'll be dealing with a lot of different unstructured data, and we can represent these data in form of arrays, essentially numbers, and NumPy will be really useful in performing very optimized computations on these such on such data, right? So that's why NumPy is a really useful library. And in fact, in deep learning, we'll be dealing with images, with sounds, with text data. So there, the importance of NumPy will become really apparent. Okay, we'll not be using a lot of NumPy till the machine learning module, but we'll be using NumPy a lot when we learn about deep learning. Okay, so but I hope you guys get the motivation. Okay, so can you guys please, yeah, let me know over the chat if you are able to understand what a module is or what a library is, and how we can, uh, yeah, and why we need NumPy. Okay, so what's the importance of NumPy? Uh, why do we need such a library which can provide us very optimized computations? Okay, so okay, because every day or every second, GBs of data, in fact, TBs of data is being generated, and you have such a vast set of data, and you want to do a lot of heavy computations on these. And libraries such as NumPy will can perform billions of such computations in a second, right? And that's why we need such a library which can perform computation, but in an optimized way. Okay, so we'll be seeing some comparisons as we go ahead, but yeah, for now. So let's import our first Python library, right? So it's a very simple task. So you write your import statement, and then you write the library name, and then what you need to do. So you can provide an alias for this particular library name, right? So you don't want to use the name NumPy every time when you require a function available in this library. So we can provide a alias which is NP, and this is a pretty much very standard alias in data science in machine learning, right? So whenever people are using a NumPy, so they always write this particular statement to import this library, right? So this is how the import statement looks like, right? So you have the import keyword, then you have the library name, and then you have the as keyword if you want to provide an alias. Okay, so this is pretty evident from here. So this is the keyword import. NumPy is the module or the library which we need to import, and this is the alias. So you write the as keyword, and you can provide a small alias which will serve as a representation for this particular name. Okay, so this is what we mean by alias, right? So I hope, so alias is nothing but an alternate name for anything. Okay, so if you don't know the English terminology. Okay, so this is how we import a particular library, right? And as you can, so let me just, yeah, run this particular cell. Okay, and so as you can see, so NumPy provides, so there are a lot of documentation available, and you can go through them in detail if you want to, right? But right, so as you can see, provides an array object of arbitrary homogeneous items, fast mathematical operations over arrays, linear algebra, Fourier transforms, random number generation. So all these things can be done using the NumPy library. Okay, so you can write it as, let's say, right? So it's not fixed, right? So it's up to me, right? So I can also write import NumPy is Vikas, right? So this will work, right? So alias is nothing but just an alternate name, and NP is sort of a very standard alias, because let's say there will be situations in which you'll encounter into some errors and you will not be able to debug it. So most probably you'll search over Stack Overflow that particular error, and if you find any such piece of code which involves NumPy, so you'll always find NP there, right, in their codes, right? So NP has become, in a way, a very standard alias, and I think you should definitely avoid writing any other alias. Okay, so so this is how we import the NumPy library in our Python environment. And now, once we have imported this, so now we have access to a lot of useful functionalities available in the NumPy. So essentially what this statement is doing, so when we are importing a particular library or a module, so once we have imported this, so all the functions or the modules within it, so they are available with us, and we can access them using the word np here. Okay, so that will become very clear in just a while. So the first thing is, the most important object defined in NumPy is an n-dimensional array type called ndarray, right, which is short for n-dimensional array. Okay, so if you don't know, so this is, let's say, one-dimensional array, right? So your conventional list, which you have learned some times back, right? So this is a simple one-dimensional array, but we can have, let's say, if we have something like a list of lists, right? So you can have these objects. So maybe let's say 4, 5, sorry, right? So 4, 5, 6, right? So this will call as two-dimensional array. Okay. So the concept of dimension will become clear as we move ahead through the lecture today. But just keep in mind the idea of dimension, right? So usually how you perceive dimension. So in our physical world, we have access to 3 dimensions, right? So one is, let's say, I can go right, I can go up, or I can move forward or backward, right? So there are 3 dimensions I have access to, right? So and which we denote, let's say, using coordinate system as x-axis, y-axis, and z-axis, right? So this is how we have been learning about dimensions, but there is another way in which you can interpret dimensions, right? So dimension is in a way, so here what you have, right? So you have a collection of numbers which are denoted as a list, right? So this is a one-dimensional number, right? So let's say you'll need only one specific information to retrieve the elements of this particular array. Okay. One thing is I should make clear at this point of time, okay, as because it's really important so that you don't get confused between list and array. Okay, so you might think that, yeah, this is a list which we have learned previously, but in jargon, in NumPy jargon, essentially we can call these as arrays essentially. Okay, so list and arrays are somewhat interchangeable, but they are a bit different. Okay, and we'll learn about the difference of those, right? So if you convert a list into a NumPy array, right, so it will not be a list, it will be an object of type ndarray. Okay, so that is the most important object defined in NumPy. Okay, if you talk about these this particular two-dimensional array, right, so you need 2 set of parameters or arguments to extract a particular element. Okay, so you need access, let's say, along the this particular dimension, and then you have you need to provide information along these axes, right? So you have this, right? So in a way, rows and columns, right? So you have a tabular data, right? So you have rows and then you have columns, right? So in a way, it's 2-dimension. Okay. All right. Okay, so every item in an ND array takes the same size of block in the memory. Okay, so they take the same size of block, or they occupy the same memory. Each element in ND array is an object of data type, object also called as D type, right, which defines the data type of that particular array. Okay, so let's start with a first array. Okay, so here what I am creating a variable, okay, and then I'm writing np, okay, which we have imported from above. And now if you, okay, so I'll just delete this for now. So if you write dot, okay, so you have access to a lot of functionalities available within NumPy. Okay, so this is an example of different, so there are different modules within NumPy or different functionalities. Okay, so let's say I want to create an array, so there is an array. Okay, and now in the parenthesis here I can provide a list, right? So for example, let's say if you're creating an array of prime numbers, so we can provide 2, 3, let's say 5, 7, 11. Okay, and then you can print your prime array here. Okay, so let's go ahead and run this particular cell. Okay, so this is the array we have. Okay, and so essentially what we mean, so we wrote this particular command, right? So np dot array, and then we passed in a list which is essentially a bunch of numbers, and it is converted into a numpy array which you can visualize in this fashion. So it is nothing but some set of boxes, and each box is taking a particular value, right? So this is of course uh, array also has the idea of sequence, so that you should not forget. Okay, like list, arrays have also this concept of sequence, and therefore we'll be able to use the indexing properties as we had used earlier in the list classes. Okay, so now next what we can do, we can check the type, right? So whenever you wanted to find the type of an object in Python, right? So what you needed to do, you write the type keyword, and then within the parentheses you provide the object or the variable name. And in this particular case, prime array is nothing but a numpy ndarray object. Okay, so as you have learned that the most important object in numpy is ndarray. Okay, so this is short for n dimensional array, because numpy provides a very flexible set of constructs. So as we can provide one dimensional array, we can have two dimensional, three dimensional, four dimensional, which we cannot even visualize or interpret physically, right? So four dimensional or even five dimensional, 10,000 dimensional arrays. Okay, so uh, so n dimensional array is a generalization of the number of dimensions that particular array has, right? So in this particular case, we have one dimensional array. Okay, so this is just a single sequence of numbers, right? Now let's create another two-dimensional array. Okay, so here also we have I'm creating this variable another array. Okay, then I'm writing this np, which is the short for numpy, right? So that is the alias which we use during the import statement. And then we have the function array, okay, or the method. And then within the parentheses here we can provide a list of list. Okay, so let's see. So this is a two-dimensional array. Okay, so as you can see, so the components of the first dimension are this and then this. Okay, so as you can see, the components of the first dimension are 1 2, so and then 3 4. Okay, so these are the components of the first dimension. Okay, and then you have 1, right? So these are components of the second dimension. Okay, like 2 and 4, right? So in a way you can think of these as, right? So these are your rows, right? So these are your rows, and then 1 3 and then 2 4 are your columns. In that way you can imagine this particular thing, right? So in if you want to visualize them, so it's essentially a matrix of numbers. Okay, so you have this nested list, in fact a list of two lists. Okay, so 1 2 will occupy one row, and then 3 4 will occupy another row. And so this row is essentially the first dimension here, and then you have 1 3 and then 2 4. So this is what we refer as the second dimension. Okay, so two-dimensional array is nothing but just a matrix of numbers. Okay, all right, so now we have a 3D array. So here essentially what we need to do, so here we had 2D array. If you duplicate this particular block, okay, this list of list, if you duplicate this, so this will again be a 3D array, right? So here, as you can see, outside you have one square brackets, and this is being closed by this, and then this is the two-dimensional array which we have earlier talked about. So this is the two-dimensional array, right? So a 3D array is nothing but a composition of two 2D arrays. In this particular case, we can have more, right? So a three-dimensional array can be a three combination or collection of three 2D arrays. Okay, so if you want to create a 2D array, you'll need to club together 1D array, and if you want to create a 3D array, you need to club together 2D arrays. Okay, So this is how we'll keep on increasing the dimensions, right? So if I ask you guys to create a 4-dimensional array, so can you please write the notation for that? Just keep in mind that in your 2D array, right? So you are seeing two square brackets here, right? You're seeing two square brackets here, and of course uh, the it's closed, it's one thing here, then you have, right? So these are two one-dimensional arrays enclosed in a square bracket, and that makes it a two-dimensional array. Similarly here we have two-dimensional arrays, right? So these are the two-dimensional arrays, and they are enclosed within the square brackets. Okay, you can see here, if you talk about 3D array, so it's essentially two matrices stacked together. Okay, so now we are entering into the third dimension, right? So if you stack together two matrices, right, so this is what is eventually a three-dimensional array. Okay, now if you try to replicate this, let's say if you're able to physically visualize this, if we stack together two three-dimensional arrays, we can get a four-dimensional array. Okay, so I'll tell you so how you can construct this. So let's say you can, so we don't have to do a lot of work, so we can copy paste our three-dimensional array from here. Okay, and of course we'll provide a square brackets. We do this, and then you can provide comma, and then you can mention this again. Okay, so maybe I'll, okay, just adding some aesthetics so that you can relate to this. So this will be a four-dimensional array, as in two 3D arrays are separated by comma and are enclosed within the square brackets. Okay, so just give you, let's start it from the one-dimensional array, right? So in one-dimensional array, you have your bunch of numbers separated by comma, enclosed within the square brackets. Now, if you want to create a two-dimensional array, so you'll need to enclose them. Let's say you can repeat this 1D array again. So maybe it can have 4, 5, 6. Okay, and then it will be enclosed within the square brackets. Okay, so you can see the two one-dimensional arrays separated by comma, enclosed within the square brackets. It constitutes a two-dimensional array. Okay, now similarly, if you want to create a three-dimensional array, so now you have this two-dimensional array, create this give a square brackets. Okay, so maybe I can add this, and now what you need to do, you need to replicate this particular element separated by comma. So you can, let's say I created this particular thing again here, separated by comma. So two or maybe multiple two-dimensional arrays separated by comma enclosed within a square bracket will constitute a three-dimensional array. Okay, similarly several three-dimensional arrays separated by comma enclosed within a square bracket will constitute a four-dimensional array. Okay, so I hope you guys get the idea. Can you please let me know over the chat if you are able to understand what an n-dimensional array is? Okay. Okay, so it's pretty straightforward. So we're essentially extending the knowledge from our simple one dimension to multiple dimensions, right? And if you talk about zero-dimensional number, so is essentially your single number one. Okay, so this is your zero-dimensional array, that in a way you can call. Okay, because we're talking about generalized property of n-dimensional arrays. Okay. Okay. So can you explain again, making an array again? Okay, sure, definitely. So let's start with a zero-dimensional array, right? So it's nothing but a single number, so maybe 2. Okay. Now, if you can stack together these numbers, let's say 2, 3, 4, separated by comma and enclose them in square brackets. So this is nothing but a 1D array. Okay. So this is nothing but a 1D array. Then you have 2D array. So here how we can create a 2D array. So firstly, what you need to do, you need to provide the square brackets, and then within the square brackets you can create multiple 1D arrays within it, right? So let's say 2, 3, 4, and then you provide comma, then you can write, let's say 5, 6, 8, something like this. Okay, so now here two, so this is an 1D array, right? And they are separated by comma, and if they are enclosed within the square brackets, right? So this will be a 2D array. Similarly, 3D array can be thought of as a stacking of such 2D arrays. Okay, so you'll have a square brackets, and then all, if you have, let's say, 5 2D arrays in your three-dimensional array, so all these 2D arrays will be separated by comma and closed within the square brackets. Okay, so this is how we write an n-dimensional array. Okay, so let's just go through the visualizations again, so hopefully that will make things clear. So this is one-dimensional array. Okay, so you just have these bunch of numbers stacked together. Now you have a 2D array, so here the 1D array like this, so they're stacked together in this particular fashion, right? 1 2 and then 3 4. Okay, so 1 2. Okay, so here you have 1 2 and then you have 3 4, so here 3 4, right? So they're stacked together in a way. So a 2D array is nothing but a stacking of 1D arrays. Then again, your 3D array, it's nothing but a stack of 2D arrays. Okay, so nothing but a stack of 2D arrays. So here you can not only move across this direction, but you can also move in this particular direction, right? In going into the screen. Okay. Okay, so Chitranjan is asking how to visualize fourth dimension. Okay, so you can search for hypercube or tesseract, but you don't have to bother about it. Okay, there are very good visualizations on how to imagine the fourth dimension, but of course you don't have to keep this thing in mind as of now. Okay, so essentially, if you want to create an n-dimensional array, so you need to first provide the square brackets, and then you'll have n minus 1D arrays stacked together. Okay, so this is a very generalized concept of dimensions, especially with respect to Numpy and linear algebra, right? So can you guys please confirm if you get the idea, right? So all the elements, so the elements of a four-dimensional array will be three-dimensional arrays, and they will be separated by comma and enclosed within a square bracket, right? So I hope, yeah, you guys get the idea. Okay, so let's move ahead. We have to cover a lot of things. Okay, so let's talk about array inspection, right? So there are various attributes which you can use to inspect your array, right? So you've learned about attributes. So if I create an object using this, right? So 3D array is an ND array object, and as you know, for every object you can have specific attributes. Okay, so in this case, right? So let's see. So first is your ND array dot shape. Okay, so this returns a tuple consisting of array dimensions and can be used to resize the array. Okay, so let's create an array, and in fact this will be a two-dimensional array. So I'm writing this variable as alma array, and then I'm writing np dot array, right? So whenever you want to create an n-dimensional array, you'll need to write this array. Okay, and then within the parenthesis, I can provide this to let's say list of lists, and this will convert our list of lists to a 2D array. Okay, so as you can see, we have stored this two-dimensional array in this variable alma array, and we can use this attribute, right? So how to call the attribute? So you write the name of the variable, and then you write dot, and then so maybe let's say you first execute this, right? So if you write dot, it will show you a lot of different attributes or functions associated with it, right? So here, what do you want to use? So we want to use the shape, right? So shape. So let's print out the shape of this particular 2D array. So this is 2, 3. So why is this 2, 3? So let's visualize this again. So this is nothing but, let's say, a matrix where you have this sort of structure, right? So you have 1 2 3, then 4 5 6, right? So there are two of these things, right? So the first value will be the number of rows here, or the number of first dimensions, and then you have three of these, right? You have three of these, right, which you can also call as columns. So this will be of shape 2, 3, right? So 2 rows, 3 columns in a way. Okay, so all right, so okay, so we can create another, maybe let's say I can add 4 here, or maybe I can add here 10. Okay, let's see what's the shape of this. So the shape of this is 2, 4, right? So you have two, so this is a 2-dimensional array, right? So you have two 1-dimensional arrays separated by comma, right? So that will give you the first element of the shape. Okay, so this is 2. Essentially, it means to say that you have two 1D arrays stacked together. Okay, and then there is 4. So that means that each of these 1D array, they have 4 elements. Okay, so I hope you get the idea how we are getting this shape. Okay, so 2 comes from these 2 units. So this is the first unit, and then this is the second unit. Okay, so 2 comes from there because there are 2 such 1D arrays. And if you look at each of these arrays individually, right, so there are essentially 4 elements, right? So this gives you 4. Okay, so if you right, so if you try to do this, right, so this gives you an array, right? So we need to be very consistent with the dimensions. Okay, so let's go ahead and create this, right? So you have 2 1D arrays, so that's why 2 is there, and in each of these 1D arrays you have 4 elements, right? So here also 4 elements, because they are all separated by comma. Here also we have 4 elements separated by comma. So that's why the shape of this 2-dimensional array is 2, 4. Okay. Okay, no, so I already gave you the answer, Tirthana. Does that make sense? Okay, so we need to be very consistent with the number of elements within those, right? So let's say if you remove, so if you wanted to have only 2 elements here, but 4 elements here, so let's see what this will give us, right? So it gives us a warning, okay, and this is not supported, okay? So we always need to be very careful, right? So the number of elements in each of these 1D arrays, they should be the same. Okay, so it was supported earlier, but now it has been deprecated. Okay, now let's create a 3D array and check out the shape. Essentially, this is my 3D array. Okay, so as you can see, there are 4 2D arrays. Okay, there are 4 2D arrays. Okay, so there are 4. So this is the third one, and then this is the fourth one. Okay, so there are 4 2D arrays. So the first value, or the first element, will be 4, right? So as you can see, so maybe I can just comment this out and print the shape directly. So because there are 4 2D arrays stacked in your 3D array, so that's why we are getting 4 from here. Okay, now what's happening, that each of these 2D arrays, okay, so this is in a sample 2D array. So each of these, they have 2 1D arrays, right? So as you can see, they have all 2 1D arrays. So bracket 4, 5, 6, this is a 1D array. Similarly, 1, 2, 3, so this is again a 1D array. So each of these 2D arrays, they have 2 1D arrays. So that's why this particular value is 2. And then each of these 1D arrays has 3 elements. Okay, so that's why this is 3. So we are sort of starting from the first level view, then the second level, and then the third level view. Okay, so I want you guys to start thinking about these 3-dimensional or even n-dimensional arrays in terms of layers. Okay, so essentially this particular 3D layer, 3D array, right? So this is one layer. So this dimension, maybe I can use, so this dimension. So this dimension gives us an first level view. Okay, so how many 2D arrays are stacked together? So that gives us the first number. Then we'll look at individually. So there are 2 rows here, right? So this gives us the second value of the shape. And then each of these rows, they have 2 elements, right? So each of these, they have 2 elements. So that's why the third element can be figured out, right? So of course in our case it was not the same array but a slightly different one. So but I hope you get the idea that the number of 2D arrays in a 3D array will be giving you the first value here. The number of 1D arrays within the 2D arrays will give you the second value, and the number of elements within each of these 1D arrays, right, like these, will give you the third element, right? So this is essentially 4 comma 2 comma 3. So we can simply multiply these things to these numbers together, and this will give us the number of elements in our array. Okay, so we'll talk about that as well. Okay, so for now you need to understand how this we're getting, right? So this is a tuple, so this is the first dimension, this is the second dimension, and then this is the third dimension. Okay, so are you guys able to understand? Yeah, so how are we getting this particular tuple, which is 4 comma 2 comma 3? Are we able to understand why are we getting this particular value, right? So always try to, whenever you want to get the shape of an n-dimensional array, think of how many n minus 1 dimensional arrays are there, right? So that will be your first number in your shape, and then think about all the n minus 2 dimensional arrays that are present in your n minus 1 dimensional array. That will give you the second number, and then so of course you can go ahead with in that generality. Okay, so but because here our n dimensional array is nothing but a 3-dimensional array, so the number of 2D arrays, that gives us the first, the number of 1D arrays in your 2D array, in each of your 2D array in fact, so that gives us the second number, and the third will give us the number of elements in each of those 1D arrays. Okay, okay, so that's great. So now let's move ahead. So ndarray dot ndim, right? So this returns the number of array dimensions. Okay, so if we have 1D array, so this will return 1. If we have 2D array, so this will return 2, right? So here also you write the name of the variable or which contains that nd array, and then you write dot, and then you can call this attribute ndim, right? I think you guys know the difference between an attribute and or a method, right? So here we don't need to specify any parentheses, right? So we just need to write the name of the attribute. Okay, so I hope yeah, you're clear about on this. Okay, so but remember when we are working with list, so list had different methods associated with it. For example, append, and there we had to provide some inputs within the parentheses, but because these are attributes, right, so we just need to write the name of the attribute to get that particular attribute value. Okay, so great. So one-dimensional array will give no particular value 1 when you write this particular code, array of integers dot ndim. Similarly, if you have a 2D array, if you write this attribute or call this attribute, it will yield you the value 2, right, because it's a 2D array. So ndim gives you the number of dimensions. Okay, now let's talk about ndarray dot size. So this is pretty straightforward. So this returns the total number of elements in the array. Okay, so if I have 10 elements, right, so this will give me 10. If I have 6 elements, so essentially the size is nothing but the product of all the numbers in your shape, right? So when we are calling this particular attribute dot shape, right, so if you multiply all these numbers together, so this will give you the size of the nd array, right? So you need to also think, why do we have these two different attributes? So of course size is nothing but the product of all these numbers in your shape tuple, but why do we have this extra attribute, right, which is size, right? So you need to think about this when you have free time, right? So of course size is available as an attribute for an nd array, but you need to understand why there's why this attribute exists, right? Because you can argue that, yeah, we could have done our work using the numbers from the shape only, right? So why do we need something extra as size? But this is really important. Okay, so both these things, shape and size, you don't have to confuse between them, right? So shape gives you the number of dimensions across different axes, right? So when we had 4 comma 2 comma 3, So 4 can be assumed to be the first axis, 2 can be assumed to be the second, and 3 can be assumed to be the third, right? Or equivalently, you can call them dimensions. Okay, so shape gives you the dimensions, essentially uh, the number of elements in all of those dimensions. Okay, so here when we talked about shape, right, so here we had 4 such repetitions of 2D arrays, so that's why 4 is there. Okay, so don't get confused between shape and size, right? So size essentially gives you the total number of elements in the array, right? So here we have a 2-dimensional array, and the total number of elements here is 6, and that is what will be the size of this 2-dimensional array. Okay, then we have a D type attribute. So this returns the data type of the array. So if you have a bunch of numbers, so we can print the data type, right? So you can write the variable name, and similarly you can write dot and then write the attribute D type, which is short for data type. Okay, now you can mix, let's say you add another string, but all the rest are either integers or floats, right? So here if I try to get the D type or the data type of this particular array, so this is something like U32, which is short for a Unicode string. Okay, so you don't have to spend a lot of time understanding what is this U32 or something like that, because in Numpy will hardly use any such operation in which we have mixed data type. Numpy is very well suited for any such operation. Let's say you have only a bunch of numbers together, right? So you don't have mixed data types. So those things, yeah, you don't have to worry about that. If we can have other data types, so for example, this is a string, this is an integer, this is a float, right? But if you print the D type, it does not show you those things independently, but it has a new data type, right? So any such array which has these elements, right, which are of different data types, so they are all considered under one umbrella data type, which is called as U32, right? So it depends upon what you're using. So for example, here also we can have an array of strings. Okay, so if we check the D type, so this is U3. Okay, so because there are 3 characters which are using, and then this is your Unicode string. Okay, so you don't have to worry about this, but mostly because you will be using Numpy for numerical calculations where you have a bunch of numbers, right? So you won't be using array of strings or maybe numbers with strings, right? So there will be very rare situation. In fact, there will be none, at least from our use case. So you don't only need to focus on arrays with very same data type, right? So they will have only numbers. Let's say they can be integers and floats, but they're essentially numbers. Okay, and then the we have another attribute. In fact, this will call as a method. Okay, so here I have created an array which I'm calling as Aravali. Okay, so this might sound to you like a pun on the word array. Okay, so this is a 1-dimensional array, and we can print the D type. Okay, so let's go ahead and execute this particular piece of code. Okay, so now you can see that here the D type is int64, but you can change the type of this particular ND array, which is Aravali. So here I'm creating another variable, Aravali underscore, and what I'm writing, Aravali dot as type, and then within the parenthesis I'm providing the string which is float64. And if you check the D type of this particular Aravali underscore variable, so this will be float64, right? So as type helps us to change the data type of the array. Okay, so this is pretty straightforward, and I hope you guys should be able to understand this particular thing, right? So essentially by the name you can conclude that we have this array of this particular data type. Now if I call this method as type, so we can convert this array into that particular data type which I'm trying to provide in the argument of this as type method. Okay, so can you guys please tell me if you are able to understand all these attributes? especially yeah, shape, endim, size, okay, and as type, right? So are you able to understand these three essentially? Okay, okay, that's great. Okay, so let's move ahead. So so one thing you might have been wondering at this up till this point of time, that why NumPy, right? So NumPy has three major functionalities or advantages. So one is memory. So NumPy data structures take up less space. Performance. So they have a need for speed and they are faster than, let's say, your lists. And then functionality. So SciPy and NumPy have optimized functions such as linear algebra operations built in. Right. So these are the three advantages of using NumPy, and I can quickly walk you through these particular things. So maybe right. So here we are importing this NumPy module as NP, and here we are importing another library which is sys, which you don't have to worry about. But this is another statement, and here I'm using some functionality on this particular module says, right, which is something like get size of, but you don't have to worry about all these things. Our idea is to understand why NumPy is advantageous, right? So if you, I created this list of 10 numbers. So as you can see, the size of each element of list, right? So this is a list. This is not a NumPy array, right? So this is a list, and as you can see, the size of each element in list in bytes. So every element is taking 144 bytes, right? And if you think about the size of the whole list in bytes, so it is 1440, right? Simply 144 into 10. Now here we have created another not list but NumPy array, okay? And similarly here we can see the size of each element of the NumPy array in bytes, 8 bytes, right? So each element in your NumPy array is only taking 8 bytes in memory, right? And the total size of the whole NumPy array is 80, right? So this particular NumPy array is taking 80 bytes in memory, but this particular list is taking around 1440 bytes in memory, right? So as you can see, so NumPy has NumPy data structures, they take up less space, okay? Okay, so Smruti Ranjan is asking, how does that happen? So NumPy functions or these NumPy functions have been written in a different way, which optimizes your space or the memory that a particular information will consume in your memory, right? So NumPy has, that's why I've been talking about a lot of optimized functions which are available in NumPy, right? So I won't be able to go into detail how does that happen, because it depends upon how NumPy has been written, right? So you don't have to delve deeper into that, but of course you can explore about that when you have time, right? So it's very good to stay curious, but understand that NumPy provides a very set of optimized functions, okay? So here the same list, it's taking 1440 bytes in memory, but the NumPy array is only taking 80 bytes, okay? Now let's talk about performance. So here also, let's say what I want to do. So here I am creating a list and then arrays of of 1 lakh numbers. Okay, so 1 lakh numbers. So I'm creating a list which has 1 lakh elements, and then I will also be creating an array which has 1 lakh elements. Okay, so now what we want to do, so here I'm creating two lists. Okay, here also I'm creating two arrays. Okay, so the first operation what we are doing, we are multiplying all those numbers index by index, right? So if you write a simple list comprehension by for element wise multiplication, so you can write in this fashion, right? So a star b, for a comma b in zip list 1 comma list 2, so it will multiply your corresponding numbers in both the lists, right? Because they are of the same size. Here also what we can do, we don't have to write those list comprehension, we can write simply array 1 into array 2. Okay, and let's go ahead and execute this, right? So as you can see, to perform the same set of multiplication, your list took around 0.01 seconds, but the NumPy array only took around 0.0007 seconds, right? So as you can see, NumPy operations are really fast, right? So are faster than what you get in lists. Okay, so okay, so they NumPy objects, they consume less memory. They are much faster as compared to your traditional list, and they provide additional functionality. So just to give you an example, so suppose I have a list here which has three elements, 1 comma 2 comma 3, and you can of course create this list as an array, which I'll call as ARR, right, short for array, right? So let's say if I wanted to add uh, a number to each of the elements of our list, right? So if you try doing this, right, so it will throw us an error, but we can do the same set of operation in our numpy array. Okay, so here as you can see, list don't support list plus n, but modify numpy arrays 5 6 7, right? So 4 has been added to all these elements, right? So the idea is your numpy array, it has greater functionality as was available in list, right? So when uh, when people started developing Python, right, so they had the initial idea of list. So they wrote codes to create a list object, things like those, right? But later on, a lot of developers realized that lists are not so efficient in a way. Okay, so that's why a lot of developers, they started working on this NumPy library, and which provides all these advantages, right? So it consumes less memory, it is faster, and then it has a lot of functionalities. Okay, so we'll be learning about all those things in detail later on, especially in the deep learning module. But for now, we'll just satisfy ourselves with these basic advantages. Okay, so now let's go ahead and look at different ways of creating an ND array. So firstly, uh, in fact, you can ignore this. Don't worry about empty for now. This is not even required. Okay, let's talk about zeros. Okay, so how we can create a numpy arrow with zeros. Okay, so I'm creating a variable zeros array. Okay, and I'm writing np dot and then zeros, and then here in the parentheses I provide the tuple, which will essentially be the shape of the array, right? So here I want a 3 comma 3 array, right? So a two-dimensional array essentially, three right? So as you can see, so this is a two-dimensional array, right? Because it just has two numbers here, and then I've created another zeros array in which I'm using this method which is called zeros, and here you can specify the uh, shape, and then you can also specify the d type int, right? So here I did not specify d type, so it created zeros, but these are floats. Okay, but if you specify d type to be int, it will create zeros which are integers. Okay, so this is the second array is a two-dimensional array, and as you can see, the shape of this array is 4 comma 3, right? So you have four of these 1D arrays stacked together, right? So four 1D arrays stacked together, and then each of these arrays, 1D arrays, they have three elements, right? So the shape is 4 comma 3. So in this way, you can initialize or create an array, and numpy array with zeros, only zeros, right? So this will come in handy later on when we do a lot of intricate operations. So, but for now, this is how we can initialize a numpy array with a given input shape, and all those elements will be nothing but zeros. Similarly, we can do the same with ones, right? So we can create a numpy array whose all elements will be ones, and here also we can provide the shape of the array, right? So here the default type again will be float, and you can provide the d type as ints. So instead of zeros, you will have to use this method which is ones. Okay, so you can provide the shape here. So maybe okay, so let's be consistent. So here you can specify a tuple or a list, but both will work. Okay, but usually we'll restrict ourselves to tuples. Okay, so as you can see, so this is creating an array of ones with shape 3 comma 3, and this is another array but of integral ones, and this is again of the same shape, which is 3 comma 3. Again, you can experiment with this. So let's say 2 comma 3, right? So it only has these many elements, right? So this is how we initialize with ones. Then a very important function which we will be using later on, this is the arange function, right? So in list you learned about the range function, right? But in the case of numpy array we have this arange function. Okay, so how can you create a list of numbers using arange? In fact, this is not arrange, this is arange. Okay, there's another method which is arrange, so you don't have to get confused, right? So these are very different, so I'll just spell them out here. So this is arrange, which is very similar to what you have learned about range, but this is short for array range. Okay, and then you have another method which is arrange. Okay, so this serves different functionalities altogether, so you don't have to get confused between these two. Okay, all right. So so here also if I write np.arange and if I write 5, so it will create an numpy array with these many elements. Okay. So this gives me a one-dimensional array with these elements which start from 1 and ends at 4. Okay. Again, what you can do, you can specify the start, you can provide the stop, okay, and then you can provide the step, right? So you already know this from the range function. So there also we could provide the start point, the end point, and the step size. Okay, so here if I want to create a list of numbers, in fact an array of numbers to be precise, so we can provide the start here, stop here, and then the step size. And of course arange, it will be within the arange, and these will be separated by comma. Okay, so in this way you can create a a list of numbers or sorry, not a list of numbers, in fact an array of numbers, right? So as you can see, 10 is the first element, then 13, then 16, then 19. Maybe if I reduce this to 2, right? So it does not include 20 here, right? So keep this in mind. Okay, just give me a second. Okay. All right. So now you are familiar with the arange function. You can in fact read about arange here. So I have the numpy documentation, and in fact if you want to search about anything, so you can consult. So for example, numpy.arange, right? So this is the start, stop, and then you can provide the step. Okay, so similarly, you can create your 1D arrays in this way. Okay, so let's look at another function which is linspace. So this creates linearly spaced values. Okay, similar to your arange, but here right, so you provide the start, you provide the stop, and you provide the number of evenly spaced values, right? So here you don't specify the step size, but the number of values which you want, right? So let's say I want 11 numbers, or maybe let's say 9 numbers between these two values, right? So it will give me these 9 numbers, right? So as you can see, so this is 5 and then there are 4, right? So total of 9. So it's only difference between arange and linspace here is that in linspace here we'll provide the number of elements which we want, okay, rather than the step size. And there are different other arguments, so which is endpoint is equal to true. So here you have 20 included. If I set this to false, so 20 will not be included, right? So here 20 is not included. Okay, so there are a lot of different arguments, and yeah, it doesn't make sense to discuss about all of these at once today, right? So you can simply work on with these things itself. Okay, so just work on these things and yeah, you should be fine, right? So don't bother about, because you're just getting started with numpy, so you don't have to know everything at once. Slowly by slowly, and of course most of the time you'll be using Google, right? So any specific task which you want to do, and you know that that can be done using numpy, so you don't have to think that oh, what was that function, let me recall, but you can simply search over Stack Overflow or search over Google and you'll get very good answers, right? So you don't have to memorize each and everything, right? So you just need to be aware that can this be done using NumPy, right? So that's what you need to focus on. And once you know that what you want to do, you can simply Google those things and you can get those corresponding functions which perform that particular task. Okay, so not everything you have to memorize or remember. So Prashant is asking, what is this? So this is the interval between each of these elements. And here, because I've specified d type as int, so that's why it's all these elements, they are of int type, but I can, in fact, yeah. So now as you can see, so the steps size is 1.11, which we did not specify. We had to specify this in the A range if we wanted to get similar set of numbers, right? And the only difference between A range and linspace is here in linspace you provide the number of elements you want, and it also returns you the step size or the intervals between those elements. Does this make sense? A range, can you guys please confirm? Right, so okay, that's great. Okay, all right, so let's move ahead. This is a really important function now which I'm going to discuss. This is random. Okay, so let's create a random function. So random array, in fact. So here what you write, np dot random. Okay, so let's see how this works. So you don't know what are the things there are in NumPy, right? So because we have used this alias np in our import statement, so we'll write np dot, and then you can search for random. Okay, so maybe it will not show all of them, right? So it only show top few, right? So let's write random. Okay, so let's write random here, and then you should write dot. So as you can see, in random you have a lot of additional functionalities. Okay, so in a way what you are doing that in NumPy module you have, let's say, a random class, and then in this random class you have this function which is random. Okay, so random, so this is how you write this. Okay, so I'll just go back to what was there, and in this here, right, so this is the main module which is the NumPy library, and in this NumPy library you'll have this random module, or let's say class, and then within this class you'll have this function which is, or method, which is called random, and this method will take the shape as an input. So here I've provided this tuple which is 4,3. Okay, so this will create a random array, but you must be wondering, so how are these numbers coming, right? So these numbers, they come from a uniform distribution, right? So these numbers are coming from a continuous uniform distribution. You'll be learning about uniform distribution later on, but to give you an idea here, right, so these are just the bunch of numbers which are present between, let's say, 0 and 1, and by writing np.random.random and then providing this shape, so it creates an array of shape 4,3, and all the values, they are between 0 and 1. Okay, all right. Okay, so just to give you another example of another function. So here within the random, let's say, class, so or module, so you have this random method. Okay, so random method will give you random integers, and here you can specify, let's say, okay, so you can specify which number you want to start with, which number you want to end with. Okay, and you need to provide the shape here. One thing you should not get confused, that in the np.random.random, here size is the argument, but eventually you need to specify the shape. Okay, so don't get confused, right? So it might have been erroneously put place into the library, but just think of this as a shape. Okay, so you need to provide the tuple. Let's say if you want to create an array with shape 2,3, so you need to provide that in the size argument. Okay, and this is the start, this is the end is not included here, right? So it will create a random 2D array of the shape 2,3, and all these numbers will be between 0 and 5. Okay, 0 will be included, but 5 will not be included. So let's say if I want to create an array of shape 2 comma 3 comma 4. So let's see how this works, right? So as you can see, there are two repeating such blocks, so that's why this shape this value 2, and then you have all these repeating 3 1D arrays, so that's why you have 3, and then all these individual arrays, they have 4 elements, right? So that's why 4, right? So what is the total number of elements in this particular array? So 2 into 3 into 4, that is 24, right? And as you can verify, there are 24 elements here. So all the numbers, they are uh, 0, so they are between 0 and 5, and but 5 is not included. Okay, so just so this random gives you random integers. And how these numbers are coming, they're coming from a uniform distribution, which you don't have to worry about. Just for now, believe that, yeah, using the random or random function gives you a random set of numbers. Okay, that's it. For now, yeah, just keep in mind that the random or random gives you a random set of numbers. Okay. Okay, so Sumanta is saying that every time we run the random code, output will change. So let's go ahead and verify. So as you can see, let's say 0412 was here in the last. Let's go ahead and create. So now, as you can see, it has been changed, right? So it's randomly taking these values or these numbers from a uniform distribution, right? So yeah, it will be different. Okay, so it's essentially sampling from a uniform distribution, and these things will become clear when you learn about probability and statistics. Okay, so for now, just believe what I am saying. Okay, I'm not saying anything wrong, but you're not that equipped as at this moment to understand how this is working. But because it's a very important function in Numpy, so I felt that, yeah, I should discuss this. Just think that, yeah, random or random gives you the random set of numbers. That's it in your array, right? So random will give you numbers between 0 and 1, and random will give you numbers between two specified stop and ending points, where end point will not be included, and it will all be integers. Okay, so that's it. Okay, so these things, yeah, you don't have to worry about. I've included this, but these are essentially optional reading concepts, right? So now there's one thing. So earlier, what we are doing, so when we wanted to convert a list to an array, so what we are writing, so np.array, and then we're providing the list within it, right? We can also do the same thing using the np.asArray method, right? So it will convert, let's say, a tuple or a list which can be provided in the parenthesis, right? So this is asArray method, and we can provide the list or a tuple as an input to this particular method, and this will generate the corresponding array. Okay, so essentially the same thing as np.array. I'll not go into the details of this because we have not a lot of time, and we want to discuss few things. Okay, and these are not that important at this point of time, because you'll only be using very few functions going ahead. Let's say when you're doing exploratory data analysis using pandas, like let's say np.reshape or things like those, but a lot of these functions which I am walking you through, those will be heavily utilized when you go to the deep learning module. Okay, so you don't have to worry about if all these things seem pretty heavy to you, or a lot of new functionalities or methods are being overloaded or bombarded to you, right? So you don't have to worry about all those things. And in fact, you should develop this habit, right? So you should be aware that what you want to do, right? So you should be aware that, yeah, if I want to do this, I can do this using some functionality in Numpy. That awareness you should have. But how to exactly write the code for that, you can simply Google it, right? So maybe let's say I can Google something like create a list of integers. So maybe, so what I can, so create an array of random integers in Numpy. Okay, so this is what I want to do. I don't know what's the thing, right? But as you can see here, there are a lot of options, and you can click on this and you can read how this works, right? So it's pretty straightforward, right? So there's nothing there's nothing like you need to memorize or learn all these by heart, right? So you should only be aware about whether this functionality exists in NumPy. Can I do this? Once you know that, then you can simply Google it and do that particular task. Okay, so you need to ask, can I do this in NumPy? If the answer is yes, even if you don't know how to do this, you can simply Google it. Okay, so I hope you resonate with this idea, and similar will be the case in pandas as well. So because pandas and NumPy, they are very huge libraries, right? And they have been developed in collaboration with thousands, in fact, thousands of developers. So a lot of people have contributed, and there are a lot of functionalities associated with a NumPy library or the pandas library, and you don't have to learn everything, right? You don't have to memorize everything. You just need to have this awareness. Can I do this in NumPy or in pandas? And then you can simply Google those things. Okay, so how to do that part can be simply Googled, and there is no shame in Googling these stuff, right? So because there are thousand, in fact more than that, operations or functionalities available in NumPy, and it's not possible to remember all of those things, right? So even I don't remember all these functionalities, but I have this awareness that yeah, I can do this particular task in NumPy or in pandas, but how to do part I can simply Google, right? So I think you all should learn this particular practice, right? Googling is not a shame, but you should have this awareness. Can I do this? Okay, all right. Okay, so let's talk about indexing and slicing arrays. Okay, so similar to list, we can do the similar operations of indexing and slicing in arrays as well, right? Here, needless to say that indexing begins from 0. Okay, so let's talk about slicing 1D arrays. So let's say this is your 1D array. So this element has the index 0, this element has the index 1, and this element has the index 2. Okay, so if you write something like data and then within square bracket 0, so this will fetch you the first element of the 1D array, which is called data. So this will give you 1. If you write 1 here, so this will fetch you the second element. But let's say, so this was indexing, but let's say if you want to grab a slice of the array, okay, so let's say you want the first 2 elements. Okay, so similar to how you have been providing the slicing arguments in list, the same thing will apply here for ND array as well. Okay, so in this case we have this 1D array data, and I want to grab the first 2 elements, so I can write 0:2. So this element at this index 2 is not included, so it will only return the first and the second element and not the third element. Okay, now if I want to have all the elements so all the elements starting from the second element, so I can provide 1:, and I don't have to specify the ending index, so it will grab all the elements in your array. Okay, so I can simply run these things and you can get the idea, right? So this is nothing new, right? So it's essentially the same thing what we have learned about indexing and slicing methods in list or maybe in tuples or strings. Okay, so now let's talk about a 2-dimensional array. Okay, so these things you already know. Okay, so this is essentially the same thing what you have learned in list. Okay, so there's nothing new to teach here, but let's say if you want to create an array of number using the random method, this is of course new to you, right? And as you can see, let's say if I want to get these elements, okay, so I can provide, let's say 4. Okay, so this is the step size, and then this is the starting element, ending element, and the ending index, and this is the starting index. Okay, so you already know how these step size thing work, right? So you have learned about the double colon. This is essentially what that is, right? So let's say if I don't specify anything here, so this will give me the elements, alternate elements, right? So 0.66 and then 0.65, then 0.58, and then 0.33, and then 0.74, right? So this is what you already know from earlier, right? So there's nothing new to teach here. Okay, so now let's talk about slicing 2D array. Okay, so let's say this is our 2D array, which we call again as data. So okay, so if you write data in bracket, you write 0,1. Okay, so earlier what you used to write, so you only used to specify a single thing, right? So whenever you wanted to grab a particular element, right? So we're providing this even for a nested list as well. So what do we used to do, right? So let's say you have this list 1 comma 2 comma, right, and then you have 3 comma 4. So let's say I want to extract this one. So what I can write, let's say this is L. So I can write L 0 and then 0, right? So this is how we're used to write. We never wrote something like a 0 comma 0. Okay, so we never wrote something like this, but because we are dealing with two-dimensional arrays, so we can use those particular aspect of things. So let me just walk you through an example, and this will become really clear to you, right? So let's say I have a 2D array in which I have this two 1D arrays. This first is 1 comma 2 comma 3, and then you have 4 comma 5 comma 6. Okay, so let's say if I want to execute 0 comma 0, okay, so this will fetch me the element at the 0 index, right? So how do you scan for this particular index? So you move along in this particular direction, right? So this is the 0th index, this is second index, and the first index. Sorry, let me be very precise with the terminology. So this is the 0th index, this is the first, this is the second. Okay, so this particular 0, so this corresponds to this. Okay, so now we have, so if I just write A0, okay, so let me just clear this. So if I write just A0, maybe let me just, if I just write 0, so this gives me the first 1D array here, right? So this is 1 comma 2 comma 3. Remember, this is a different example, this is not the same as what we're taking here. Okay, so A0 gives you 1 comma 2 comma 3, 1 2 3 in fact, right? So here one thing you might have noticed, right? So when we are printing the array, so the elements are not divided by are not separated by comma, but they are separated by space here. Okay, so this is a difference from your traditional lists. Okay, so I hope, yeah, you guys have already noticed this. If you haven't, so yeah, you can realize this now. Now if I want to write 0 comma 0, so this will give me the 0th element at the 0th index of this particular element, right, of A0, right? So that's why I'm getting 1. Maybe let's say if I want to get the 1 and then 2, so let's see how this will work. So index 1 corresponds to this second element, which is 4 comma 5 comma 6, and then 2 will correspond to the third index, third element, right? So this is 6. Okay, so I hope, yeah, you are able to understand how this works. Now similarly here we can have this slice. So for example, let's say if I want to get all the rows here starting from the second row, right? So this is the first row, we don't want to consider the first row, we want to consider all the rows starting from the second one. Okay, so here we can specify 1 colon 3, right? So here if you don't specify colon, so this will automatically take the first layer of things, so it will do the slicing operation in the first layer. Okay, so I hope you are aware about this particular terminology, layer, right? So I have asked you guys to understand an n dimensional arrays in terms of layers of the lower dimensional arrays, right? So a 3D array is essentially a stack of 2D arrays. A 2D array is nothing but a stack of 1D arrays. A 1D array is nothing but a stack of numbers, which is essentially your 0-dimensional array. Okay, so I hope you get the idea of how to do indexing and slicing here. So again, so we can provide 0 colon 2. So if I want to grab the first two elements of our first layer, okay, so for what are the first two elements of our first layer? So these two elements, right? So 1 comma, so this is this list and this list. Okay, and then I want to have in the second dimension, because here we are only talking about 2D array, so here I want to have the last two columns or the last two values of the second layer. Okay, so in this analogy, the first dimension is your rows and the second dimension is your column. Okay, so okay, so let's see how what this will give us. So maybe I can, yeah, or in fact I can print the list, print the array. Okay, so this is the two-dimensional array we have, and we are taking the first two elements. So essentially what we are doing, so we are focusing on these two elements firstly, right? And then maybe I can yeah, write something else which will help you understand how this is happening. So maybe I'll just get rid of -2. So now you can see, so A was this initially, now 0:2, that means grab the first two elements, right? So which are these two elements? So 1 1 2 3 and then 4 5 6. Okay, so it's skipping the, or it's not considering the last one. And out of this we are providing that take the last two columns. Okay, so it's not considering 1 4 here, it's only considering 2 5 and then 3 6. Okay, so this is the final slice we have. So because we are taking a slice, we do not have a single so we are taking the slice here, right? So any slice of a 2D array will give you a 2D array only. Okay, but if you just have single index numbers there, then it will get you the individual elements. Okay, so I hope you understand the difference between the slice and the index. Okay, so the slice of any 2D array will give you a 2D array only. Okay, so now comes the task of slicing 3D array. So similarly here we'll have two commas. So one slice operation which we want to provide, we can provide here. So here you can provide the range of indices. Then in the middle you can provide another range of indices, and here also you can provide the another range of indices. Okay, so this is our three-dimensional array, and let's see how we are getting this. Okay, so here first we are saying that we want to take the first two elements in the first layer or in the first dimension, right? So here now, so let's make it a lot simpler for you guys. So firstly oh sorry, this. Okay, so here I'll first print the array. Okay, nothing else. Now what I'll need to do, I'll print the first two layers, then I'll provide one okay, so maybe I'll just not write this. Okay, so this is your original array. Okay, and this is the first two elements, right? So as you can see here, so only these two elements are captured when I'm printing what? When I'm printing 0:2, right? So print the first two, or get the first two elements, right? So this is the first two elements from our original array A. And then what we are saying that we only need to consider, so here we are saying that we need to consider all the columns. Okay, so in fact okay, so let's run this again. Okay, so now here what we are saying that in the middle, right? So we are saying that this is a different operation. Okay, so this is the first two element which you already know, right? So this is the first two element. Now we'll be looking at which 1D arrays we need to select. Okay, so which 1D arrays we'll need to select, so which come after the index or the position 2. Okay, so here we'll not consider this, neither this, right? So not this particular thing, nor this particular thing. Okay, because we are providing one colon. Okay, now once we have done this, so we'll be getting 3 4 5 6 and then 9 10 11 12, and then we are saying that take all the columns, right? So because it's starting from 0, so which doesn't do anything extra at all. So maybe I can provide 2, and as you can see the difference here, right? So it's giving me nothing. So maybe I can just write 1, right? Because it only had 2 columns, right? So as you can see, it's giving me the second column, right? So 4 6 and then 10 12. Okay, so are you guys able to understand how we are slicing the 3D arrays, right? So the first slice corresponds to, or this first range of index corresponds to the first set of layer, which will correspond to your n-1 arrays which are stacked. The second will correspond to the n-2 arrays which are stacked in your n-1 D array, and then final will be your essentially the elements in your those n-2 dimensional arrays. Okay, so I hope you get the idea, right? So okay, that's great. So okay, so I hope you understand now, right? So let's look at different manipulations or different transformations which we can do on a NumPy array. Okay, so of course you need to understand how these slicing techniques work, right? So in the case of a list, so maybe I can give you an example. So let's say if we have a list, so which is, let's say, a list of lists. So here I can have 1 comma 2, and then I can provide, let's say, 4 comma 5. Okay, so if I wanted to get the first element, so this will give me 1 comma 2, and then I wanted to get the 1, so it will give me 1, right? And okay, so here also maybe I wanted to, let's say, have 0 to, let's say, 1, so this will give me a slice of this, right? And then of course maybe you can specify this to, right? So this gives you an error, right? So list indices must be integers or slices, not tuples. Okay, so this is what it's different. So maybe let's say, so this gives you a null. Maybe I'll consider 0 to 1 again, right? So this will give me 1:2, right? So this is nothing but 1:2, right? And then here again we are asking it to do the same thing, so it will give me a list of list only. Okay, so so you understand hopefully why we have commas here. Okay, so this will correspond to the first dimension, this will correspond to the second, and this will correspond to the third dimension, and always try to think of these dimensions as layers. Okay, so I hope you'll get more clarity on that. Okay, so don't worry about the list objects as of now, but you can of course experiment with these particular set of things. So as I was saying, right, so you cannot provide a tuple within the square brackets, let's say, for your list of lists. Okay. All right, so let's look at some operations which we can do using NumPy. So there are 4 operations which I thought you should understand. So one is transpose, another is reshape, the another is resize, and the other is flatten, right? So these are fairly easy to understand, and of course you can go into a lot of details and depth, right? So transpose, you know how it is defined. So transpose is defined as an operator which flips a matrix over its diagonal. That is it. It switches the row and column indices of the matrix A by producing another matrix, often denoted by A transpose, right? So let's say you have this matrix which is of shape 3 comma 2. Then you can do the transpose, so your rows will become your columns and your columns will become your rows, right? So as you can see, so 135 was one column, but here when we're doing the transpose, so 135 is now a row. Similarly, 246 was another column. Now here 246 is another row, right? So we are essentially flipping the rows and columns. Okay, the number of elements eventually will remain the same. Okay, so let's create an array which I'm calling as Aravali. And how am I creating this? So I'm creating this using the random function, and all these numbers will be between 10 and 45. And the shape of this array is, let's say, 8 comma 2, right? So 8 rows, 2 columns. Right, so this is our array, and the shape is 8 comma 2, as you can see from here. Now let's call the transpose method. So we'll write np.transpose, and then we'll provide the array Aravali, and I'm storing the output from this to Nilgiri. Okay, so let's see what this returns, right? So now this returns an array with the shape 2 comma 8, right? So earlier it was of the shape 8 comma 2, but now it is of the shape 2 comma 8, right? So this is what transpose does essentially. Okay, so you can play around with 3D array as well, and I think these things should be very intuitive and straightforward to you guys, right? So how we are flipping, in fact, changing the rows and the columns, right? So but here we have three dimensions, so you can inspect, okay, and why are we getting these things here, right? So maybe, So this is an array which we have created, and let's do the transpose of this. Okay, so now as you can see, the shape was earlier 3 comma 2 comma 4, but now it's 4 comma 2 comma 3. Okay, so we had 3 elements in the first layer, but now here we have 4 elements in the first layer, right? As you can see, 1 2 3 4, but here we have 1 2 3, right? So I'm talking about the first layer, right? So as you can see, the shape has been changed using the transpose operation, right? So this is fairly straightforward, and you don't worry if you're not able to comprehend that much, because we'll be studying about transpose in linear algebra, right, when we talk about matrix algebra specifically. Then you have np.reshape, right? So essentially what this does, so it gives a new shape to an array without changing its data. This is really important. So without changing its data. Okay, so let's say if I have an array or a 1D array of 6 elements, so I can reshape this to a 2D array of shape 2 comma 3, right? So the number of elements are essentially the same here. Also we can reshape this to 3 comma 2, right? So the number of elements will remain the same. So we won't be able to reshape if there is an inconsistent number of elements. Okay, so let's take that particular example. So I have this 2-dimensional array which I'm calling as random cohort, and this is nothing but an array with the shape 3 comma 8. Okay, so but we can transform or reshape this particular array with a new shape which will be 2 comma 6 comma 2, right? So 2 elements in the first layer, 6 elements in the second layer, and 2 elements in the third layer. Okay, or you can also call them equivalently as dimensions or axes. Okay, so as you can see, so all these elements, so as you can see, the size is the same, right? So 3 into 8 is 24. Then you have 2 into 6 into 2, which is again 24. Let's say if I want to do 3, can I do this? Right, so it says that cannot reshape array of size 24 into shape this, right? So here, whatever new shape you are reshaping your original array into, you need to keep in mind that the shape of both the arrays have to be the same, right? So size has to be consistent, right? So it can be, let's say 2 comma 4 comma 3. This is also permissible, right? Because here the size will again be 24, right? So 4 into 2 is 8, 8 into 3 is 24. Okay, so now let's talk about okay, so maybe we can skip these things. Okay, so there's another operation that we can do, which is resize. So resize changes not only this shape but also the size of array in place. Okay, so this is essentially an advanced version of your reshape. So in reshape, the only constraint we had that the sizes of both the original array and the transformed array, they have to be same. But in the case of resize, we can change the size as well. Okay, so let's see how we can do that. So first we'll create a random 3D array, right? So this is the 3D array we have, okay, whose shape is 2 comma 4 comma 6. Now let's say the new shape is I want to provide 2 comma 3 comma 6. Okay, so as you can see, the size is not same here, right? So 2 into 4 into 6 is nothing but 48, and 2 into 3 into 6 is 36. So let's see what happens in this case. So as you can see, it's only picking these top numbers. Okay, so it's not including or not even considering the last 2, right? Because we asked Numpy to resize our array, and the size of the transformed array has to be 36. That means there will be 36 elements. So how Numpy is picking those 30 elements? It's picking all those first 36 elements. Okay, we can also increase the size of this. Okay, so maybe 4. So let's see what this gives us. So it gives us 4 comma 3 comma 6, 12 into 6. So here what will happen, right? So maybe I'll just show you. So this is your original array, right? So this is your original array, and when we are doing this 4 comma 3 comma 6, right? So as you can see here, it's starting from 90. So these elements are essentially being repeated again, right? So once it has exhausted out of all those original 48 elements, so it's just repeating those elements again. Okay, So this is how the inconsistency in size is being handled by the resize operation, right? So if you provide the uh, new shape whose size is lesser than the original one, so it will take those first set of elements until it exhausts. If you provide the new size to be greater than the original size, so what will happen in that case? So it will, once it has exhausted out of all those elements, now it needs to fill the remaining ones. So it will just start from again, right? So it will start repeating from the beginning only. As you can see, 19 has been, yeah, 19, 40, 26 was present earlier. So it's just now repeating, yeah, copying those things. Okay. So this is your resize. Okay. And then finally we have flatten. So this what this does, it returns flattened 1D arrays. So suppose I create a 3D array of shape 2 comma 4 comma 6, right? So this is a 3D array. So now what we can do, so we can call this array, and we can call this particular method, which is flatten, and let's execute this. So this will give us a one-dimensional array, right? So all the elements will be in sequence. Okay, so I'll leave it up to you. So how you are deciding how those elements will come in order, right? So just try to play around with this. This is fairly straightforward. So I can tell you for a few elements, right? So these 5 elements are there, right, till 38. But now, yeah. So and then the next set of elements is nothing but these elements, right? So 32, 39, 24, 24, 44, 32, right? So in same fashion it goes. Okay. And then yeah, you don't have to worry about this, right? So in this way, flatten essentially flattens your 3D array. Okay, so maybe let's see what is our random 3D cohort now, right? So this, right, so when we applied this flatten method, right, so this did not change our array, right? So this is our original array, right? Okay, so I hope, yeah, you get to understand this particular concept, right? So these are the 4 basic operations. In fact, there are more operations than these, and of course you are free to learn about them online. You can go through the Numpy documentation and learn about all those functions which are there, but we don't have to bother ourselves with a lot of things, right? Because we'll not be using them eventually. Okay. All right, so now let's just have a look at the final set of concepts. So the difference between copy and view. Okay, so the main difference between a copy and a view of an array is that the copy is a new array and the view is just a view of the original array. So the copy owns the data, and any changes made to the copy will not affect the original array, but any changes if you're making to the origin to the view, it will change, right? So what do I mean by that? Let's take an example. So let's take an example of a list. Okay, so this is how we define a list. Now what we do, we assign this list to another variable b, right? So b is now a view, right? So it's not a copy. So what this implies essentially, so let's say if I try to update the first element of my list b to 10, right, and I can print both b and a. So let's see what happens. So as you can see, my original list A has also been changed, right? So the first element has been updated with the value 10. Now let's take another example where what we write, so we just don't write A, we write A dot copy, right? So there's a copy method which will create a copy, right? So now B will occupy another memory location. Okay, so if I do the same operation, so now as you can see, when I'm printing A, it does not change. Yeah, my original array is not getting changed, right? So this is the difference between a view and a copy. So whenever you write something like b is equal to a, you're creating a view. Essentially b points to the same memory where a is. Okay, but in this case, when you're using the copy method, so b is a list object which takes another memory location, right? So it's not pointing to the same memory location as a. So that's why whatever changes you're making to B, it only gets reflected in B. But let's say when you're creating a view, right? So whatever changes you're making to B, that will also be reflected in A, right? So that's the difference between copy and view. And if you do this, the same thing for an array, okay? So it will change both of your array, right? So here I am updating the first element to -99. So as you can see, A has also been updated to -99, 34, 12, right? But if you use the copy method, right, so it will not change your original array, right? So what is the takeaway from this particular understanding is that whenever you are dealing with objects such as list or arrays, you have to be really careful, right? So you should always avoid such operations, because whatever change you make in B, that will get reflected in A, right? So that is the case with views. But the safe option, in fact, yeah, the safer option is to create a copy, so that the new variable, it occupies another memory, and from there, whatever operations you perform on that particular new object, that does not get reflected or transmitted to your original object. So this is why you should develop this practice, that you need to create a copy before you yeah, do some transformations on array, or if, where you want to store the same set of elements as you have in some earlier or original array, right? So this is the difference between copy and view. Okay, so I hope most of you, I hope, yeah, all of you understood most of what I have tried to teach, right? And I do not expect from you people to remember everything which I have told, but I just need that you should have this awareness that, yeah, these functions or these functionalities I remember can be done using NumPy. So if I know that, yeah, this can be done using NumPy, then I can simply Google how to do that particular task. So you don't have to cram or memorize all these functions or all the arguments or those functions have, right? So whenever you can simply, yeah, hover on flatten, and then this will give you what this function does, or maybe you can consult the NumPy manual. Okay, so this is it, what we have in NumPy. Of course, there are additional things which I thought to skip, but this is available in your course dashboard, right? So for example, integer indexing, boolean indexing. Then there are other ways to manipulate your NumPy arrays, like methods such as insert, append, delete, unique, right? So you can go through them, right? And there's another important concept which is of broadcasting, right? So I didn't feel the need to introduce this concept at this point of time. When we move to deep learning module, we'll be learning all these concepts, or in fact revisiting these concepts there, right? So you don't have to worry a lot that, yeah, there are so many things to learn in NumPy. How do I yeah, keep pace, etc., etc. So the thing is, if you consult the NumPy documentation, everything is available there, right? So whatever task you want to do, you can simply search the manual or search Google Stack Overflow, and you will get to know how to do those particular tasks. But the main thing which is expected from you, that you should be aware that what task you need to do. Okay, that is really important. Okay, so just go through this additional material, and you'll get to have some more understanding of various other functions, right? So like aggregate functions such as sort, min, sum, max, etc., right? So try to, yeah, understand these concepts. Here also axis is essentially the same thing which I have talked to you about. So axis is nothing but the layers. Okay, so 0 means the first layer, 1 means the second layer, okay, and the third, and let's say axis is equal to 2 means the third layer, and so on and so forth, right? So there's no such difference in terms of that, but this is a really important concept of access, and this will be using, and when we discuss a pandas operation, so we'll be using axis there, and that will become clear there. Okay, so yeah, so if you have time, you can go through these operations, but this is optional. We'll in fact come back to this and revisit this when we learn about deep learning, right? So you don't have to worry a lot, but keep in mind, so these basic functions, and you'll be using some functions of NumPy in exploratory data analysis when you do using Python pandas. Okay.